Now we're doing an ellipse. This is number 2. And this just notation here, semi-major axis we usually call A with ellipses, and semi-minor we call B. So the semi-major axis is 7, the semi-minor axis is 3. And we know that this is going clockwise. So we know that x of t needs to be sine then, if it's going clockwise. And y of t needs to be cosine. And it doesn't actually matter where the 7 and the 3 go. Let's say that we make it 7 and 3. Then that ellipse would look like this. 7, -7, 3, -3. And we can draw our ellipse. Okay, and because sine comes first, this is going to be moving clockwise. Okay, but we could also do 3 sine t and 7 cosine t for x and y. And then if that's the case, then we would go 7, 7, 3, 3. And now the ellipse is vertically elongated. So that part doesn't matter. You can pick these, but just make sure that sine's coming first and cosine's coming second, or sine is x and sine is x and cosine's y, and then one of the coefficients is 7 and one of the coefficients is 3. That gives us our ellipse moving clockwise. In Desmos, if you want to determine the path, then you would have to type in 3 sine A, comma 7 cosine A, or do it for this one. Okay, so now we need to determine dy dx. So I'm just going to do this for one of these because it's the same method, regardless of where you put the 7 or the 3. So I'll just do it for this one. So to determine dy dx, we have to determine dx dt and dy dt first. So dx dt, the derivative of sine is cosine, so we have 3 cosine. dy dt, the derivative of cosine is negative sine, so this is -7 sine. So now we have dy over dx is just going to be -7 sine t divided by 3 cosine t. And this is going to determine the slope of curve at t.